The next topic will be about nomenclature of heterocyclic compounds. In early days, when you still have not so many of them, people use common names to call them. For example, this one is furan, this is pyrrole, and this is thiophene. And we still use these names nowadays because they are popular. But later on, when you have many more of them coming up, the common name is not suitable anymore. Otherwise, you need to remember all of them. There are so many. So you need to devise systematic names, and that system we are going to focus on the Hunts-Widman system in this lecture. Okay. So as you can see, for furan in the Hunts-Widman system, it is called oxo. This is called azo, and this is called thiol. And I will teach you how this system works. Before we move on to the systematic names, there are some common names that are so useful that I would like you to remember, and I will expect you to remember all of these. Okay. So later on in lecture 4, we will focus a lot in the synthesis and reactivities of pyridine, quinoline, and isoquinoline. Okay. In lecture 5, there will be furan, thiophene, pyrrole, and indole. Okay. In lecture 6, we are going to talk a lot more about the heterocyclic compounds that contain more than one heteroatoms, which are oxazole, thiazole, imidazole, isoxazole, isothiazole, pyrrozole, and also triazole and tetrazole. Okay, and that would be all of our first half of the course, which will be heteroaromatic compounds. Okay, these are non-aromatic compounds, which will be covered in the second half of the course. Some of the important ones are oxirane, thyrane, aziridine, pyrrolidine, piperidine, tetrahydropyran, and dioxane. I think some of you might have heard these names before, but they are very useful that I recommend you to remember them all. Okay. For the systematic names, as I mentioned that we are going to use the Hunt-Widman naming systems. It is based on 4 rules. Rule number 1, when you have a look at your heterocyclic ring, you need to find out what is the heteroatoms, and then this will give you a prefix. Look at this table. If there is an oxygen atoms, then the prefix would be oxa. If it is the sulfur atom, it will be thia. If it's a nitrogen atom, it will be aza. Okay. If there are more than one heteroatoms in a ring, then you use priority order from left to right in the table. For example, if you have oxygen and nitrogen both inside the ring, then you will use oxa as the main priority. Okay. And when you have these prefix, when you want to combine it with something else, there is also a rule that if the next syllable starts with vowels, for example, aza, and then the next thing you add is irene, then you cut the a ending. Okay, so you cut the a out, and it becomes azirine instead of azairine. Okay. For the next rule, you need to consider the ring size of the heterocyclic compounds. So look at this table. If your ring size is 3, then you add IR next to the prefix. Okay. If the ring size is 4, then you add ET next to the prefix, and so on. After that, if your ring is fully unsaturated, which means you have double bond alternates with single bond, okay, you will conclude the name with a suffix for different ring size. For the ring size of 3, you add the suffix of "-ine", okay, except for nitrogen that you use "-ine" instead. For the ring size of 4, 5, or 6, you just add "-e", okay, and for the ring size of 7, 8, or 9 atoms, you use "-ine". Let's have a look at this pyridine as an example. You have nitrogen as a heteroatoms, right? So it needs to start with Asa. Okay, and then you have 6 atoms in the ring. So you need to follow it with In. And for the suffix, it is 6 atoms. So you add E at the end. And don't forget that when the prefix is followed by vowels, then you need to cut the A out. So at the end, it becomes acene. Okay. For this compound, you have heteroatom as nitrogen as well. So it starts with Asa as well. Okay. And then it has 3 members in the ring. So you need to use IR. And then after that, it has 3 atoms. So the suffix would be "-ine", but it is nitrogen. So we use INE instead. Okay. And you cut the A out. At the end, it becomes acerine. Next example, you have heteroatom as S. So it is Saya, right? And then you have 4 members in the ring. So it's ET. Okay, and for the 4 members, the suffix is E because it is fully unsaturated, right? So at the end, you cut the A out and it becomes thiete.
For rule number 3, we talked about the suffix for the fully unsaturated system. But for heterocyclic compounds with fully saturated system, we use different suffix. For all ring sizes, we will use the suffix of "-ane". Apart from the heterocyclic compounds that contains nitrogen, which we use "-idene" for ring size of 3, 4, or 5 atoms. And for 6 atoms, we use the prefix of hexahydro instead. And there are also several exceptions as well, which I cannot cover them all, but some of them would be, for example, we will use the name oxane instead of oxynane for the 6-membered ring with oxygen present.
For the first example, you have oxygen as a heteroatom, right? So you need to have the prefix of oxa. After that, your ring has 3 members, so it follows with IR, right? And then at the end, because your ring is fully saturated, that means the suffix needs to be "-ane", and you cut the A out. So at the end, it becomes oxyrane. For the next one, this time you have nitrogen as a heteroatom, so it starts with Asa. After that, your ring has 4 atoms, so it follows with ET. And at the end, because your ring is fully saturated and because it is nitrogen, so you need to use idene for ring of 4 atoms. So at the end, you need to use idene and cut the A out, so it becomes acetidine. In some cases, you may see an extra hydrogens inside the heterocyclic rings, and as you can see in this example, that the position of the hydrogen affects the structure of the molecule. For example, for 1H pyrrole, this extra hydrogen is at the number 1 position. That's why you need to specify that it is 1H pyrrole, but actually it can tautomerize to other position as well. So for example, if you protonate at this position instead, you have an extra hydrogen here at the number 3 position. So you need to specify that this is 3H pyrrole, and it can tautomerize again, right? So if you protonate here instead, now the extra hydrogen is here at the number 2 position. So now it should be 2H pyrrole. As you can see, all the 3 structures are 3 different molecules, but if we don't specify the position of H, all of them are pyrrole, okay? But they are 1H, 2H, and 3H pyrrole. When you have substituents, for example, these methyl groups, so you need to see what is the base structure of this pyrrole. So it is correspond to the 3H pyrrole, right? So this is your base structure. but the two methyl groups is attached at the third position, so it must be 3,3-dimethyl, and then the core ring, which is 3H pyrrole. These are some examples that you can attempt. If you want to try out, you can pause the video here. I give you 5 seconds to pause. And for you who have already tried the video, I will give you the answers of each compound. Don't forget if you don't get it right, because sometimes there are more than one way to name the structure, and also there are lots of exceptions, so don't worry about it. As long as you follow the rule, then it should be fine.